the main area or the main show will be on this 1 square meters, so you should position yourself to see it besides the screen, of course. Alright, so this is going to be, I'm Roland, by the way, I'm working at instructor, but that really doesn't matter. So what this is going to be, it's going to be a LED lighting system, LED lighting system. And first of all, I'd like to talk about the motivation of this project. So there are some products on the market, some pretty successful products like the Philips Hue and the Visual Vibes, you might have heard that. And these are good products to light up your rooms with LEDs. And I really like LEDs, so I wanted to light up my room. But they are expensive. The Visual Vibes is around $1,000 if you want to light up like 20 meters of your room. And the Philips Hue is like infinite amount of money. But even if you do have the money, because let's be honest, we are developers, so that shouldn't be a problem. But what I really hated in these products that these all have these predefined list of effects that you can choose from. And yeah, you can play with the color and with some other parameters as well, but it's really restrictive in terms of effects. I wanted something more generic. And also, they do have music support, so they can light up for music, but they are like, you should connect the cable, the audio cable to them, and that's how they do it. So they don't have Spotify support, for example. And yeah, this is not true, so this little asterisk here is just Philips Hue just released their Spotify support 2 months ago, so yeah, they stole it from me. Totally. So yeah, let's talk about features. Can you see those texts? Not really, right? Doesn't matter. So how it works? So my abstraction here is that I define. So yeah, I want to talk about how do you make these generic effects. That's what I want to talk about. So my abstraction here is that I'm defining these little segments. What I call a segment here is this contiguous group of LEDs, and they have properties like color, the size, the intensity of the light. And yeah, on this first image, you can see one segment, which is about 5 LEDs long and red color. On the second one, it has 2 segments. They are a little bit bigger. And on this bottom one, there's a lot of little segments. So that's my abstraction here. And what you can do, if you can see this text, is that I have these action types that, for example, I can create a segment, I can define the color for the segment, I can define the size of the segment, the intensity of the segment, and I can also make these transformations for them. So for example, I can put a move transformation to the segment, and this means that it will, so the segment will move on the strip with 150 LEDs per second, and it will accelerate with -80 LEDs per second squared. And also it has a dim transformation, so it can change the intensity of the light. So that's a JSON descriptor for, so that's how a JSON descriptor looks for the segment. And yeah, let's see how it looks like. So it creates a segment on both LED strips. So by the way, it's separated to 2 different LED strips. This is the first one, and that's the other one. And it's going to be like 3 LEDs long. It's going to be white, and it's going to move and dim the lights from 1 to 0. So let's see how it works. So this is my test. So we are just going to execute that JSON, and that's what we are going to see. So it created 2 little segments, and it applied that move and dim transformation, and that's what you saw here. Yeah, so that's what I made to make this a little bit more generic. So you have all kinds of features here. Like you can move them, you can dim them, you can fade different colors, so you can go from white to orange, for example. You can change the size. There are timer-based actions, so you can repeat actions in different time intervals. There are events. So, for example, if a segment reaches a certain amount of position, then it's going to trigger another action. And also, it is able to synchronize with music. So let's see them in action. So you already saw this test one, and for example, here's a simple move. Like it's basically the same as before, but you know it doesn't dim and it's a little bit slower. I have a cool move effect, which I don't know what it is, but yeah, so it's more segments with different colors and with different speeds and acceleration. There's a very cool move where you can see that segments can go to all directions with all kinds of colors. So they can dim, so they can change the intensity of the light. So they can fade, which means that they will fade from one color to another. I think it's going to be from white to orange, yes. Yeah, and it's not going to disappear, so I have this nothing effect, which just makes them disappear. And yeah, they can change their size as well. So they just appeared at the top and the bottom, and they continuously change their size and they grow. And you can see another interesting feature that if two segments overlap each other, the colors are added together. So from the red and the green, there's a yellow. And again, I need my nothing effect here because I don't have any way to. Yeah, you can see timer actions here as well. So it's a timer-based action. It continuously, in every second, creates new segments. So it's a never-ending effect as well. So that's kind of all the features now. So let's move forward. And yeah. So about the architecture. This best boost is the name of this project. If you were wondering. So, I got a hardware, which is a Raspberry Pi. It didn't start as a Raspberry Pi, I started with an STM32, but yeah, I had memory issues. And also I wanted to write C++ code, which they handle very strangely. So I switched to Raspberry Pi. And yeah, so there's a C++ application running on the Raspberry Pi, which basically gets this JSON descriptor and it converts it to digital signal. That's how the C++ application works. There's also a middleware, which is a Node.js application. The only purpose of the middleware is that I was lazy to write a WebSocket connection in C++ because that's very hard and it was so much easier in JavaScript. So basically, it's just a proxy between the backend and the C++ application, so they can communicate with WebSocket. And there's a backend and a frontend. The backend is written in Java Spring, and the frontend is written in React. And also, there's a mobile application written in React Native. And I have you cannot see that, but I already have 3 downloads. All 3 of them was me. Yeah, so that's how the architecture looks like. Yeah. So why this WebSocket connection is necessary, you might ask. So what I wanted to do is I wanted to control the LEDs through browser. So I can't really initiate a communication through a browser to a Raspberry Pi because it doesn't have a public IP address. So I changed direction, and whenever you turn on this Raspberry Pi, it automatically starts an HTTP request towards the backend, and it upgrades to WebSocket. So what it does is I'm able to start a communication from the browser to the Raspberry Pi. That's why I needed that connection. All right, and about the hardware. So this is how it looks like. So this is the front end that you can see, and this is the back end. So here's the Raspberry Pi, and here's the power supply for that, basically. And here's a little hardware that its sole purpose is to convert the 3.3 data signal to 5 volts, because that's what these LEDs need. The LEDs, by the way, if you want to buy them, it's very cheap. It's this LED, WS2812B. I should have mentioned that on the slides, but now you just have to remember it. So it's like, I'm not sure, it's like 500 forints per meter.
If you buy it on eBay, if you buy it locally,
yeah, if you buy it locally, it's much more expensive, yes. But if you buy it from eBay or anything like that, it's very cheap. Yeah, so this is, by the way, just a portable version of this project, because this way I can show it in live, but you can see it in my apartment. And you can see a Christmas tree as well, because this is like a 2-year-old recording. But yeah, so this is how it looks like in 20 meters of LEDs. It's fun. Okay. And yeah, this is very interesting, because here you can see the very first versions of this project. This one was visualizing the different frequencies of the music, and this one was the very first version built by Raspberry Pi. It's a cardboard box. Yeah. So what the feature I didn't show you was how it synchronizes to music. So that's gonna be next. So first of all, we need an effect which is written to synchronize to music, and I think it should be the sync link this time. It's not going to do anything without music, except that little blue light which tells me that, you know, it's a feedback to me that, yeah, it's gonna work. And now I'm gonna go to Spotify. I'm gonna also hope that I don't have any awkward music in the recently played list. So what should be the music? You can choose.
should be your lyrics. It's personal.
You know, it should be something where you can feel the rhythm. You know. Okay. Did I hear Martin Garrix? Yeah, that's a good choice. That's a good choice. So it's gonna be Martin Garrix. So when I have some music on, I can refresh and we can see what music plays on my account. And once I'm going to press the synchronize button, then it's going to, you know, read the music, what I'm listening to, and then it's going to flash to that one. So let's see. Synchronize. There's going to be a good part here. So this is going to, yeah, it's not perfect. It's not perfect for any means, but it looks good for other songs. No, most of the time. No, this is going to be good.
It's still working, no worries.
That's good. So how it works, if you ask it, so it uses the Spotify API, and you can ask from Spotify API, so what song this specific account is listening to, what is the elapsed time in the song, and also you can download this, how it calls, this track analysis. So you can go to Spotify, make a request, and you are going to get this track analysis, which is going to be a JSON, and it's going to contain information about where are the different beats, the track segments in this audio. So that's what I'm using to convert it to lines. Yeah, so I'm not doing anything cool like analyzing the music myself or something like that. But the cool feature I just promised. So what's going to happen here is I'm going to say some sentences in Hungarian. So actually it's a feature that I'm going to translate as well. But I'm going to say some sentences in Hungarian, and the LEDs will generate an effect for me about that will somehow relate to the sentence I just said. Let me demonstrate that. Szeretnék elaludni. And it creates this calming
blue light, so it doesn't have to
it generates this calming effect that is very different from the previous one. But actually, yeah, let's have volunteers. So you're gonna know it's not a rigged presentation where I prepared some sentences that I know it's going to work. So yeah, so you're gonna be. Do you know Hungarian?
Just the ones.
Oh, that's perfect. All right, so let's try. Yeah, come here. Okay. So once I press this button, say the sentence. Somewhere here is the microphone. I have no idea where. And yeah, you can start.
Good luck.
It's the same effect. So again, it realized that it's again you need some calming, nice effect.
What about code, the source code? So it's just.
I'm gonna say a few words how it works. I just wanted to show some different examples. So another volunteer. I know Anna likes to be the center of attention. Would you like to try it? Please, come. Just think of any emotion and try to.
Where should I say?
Once I press this button. So now.
Ez a lámpás tudsz nagyon menő.
Ez a lámpás tudsz nagyon menő, which means that this lighting stuff is really cool. Yeah, so it generated some cool effect based on that sentence. Okay.
It knows only Hungarian?
It's a feature that it knows Hungarian. It theoretically it does know any language. You're gonna see how. One more, because I really spent a lot of time generating this effect. So just one more. Randi este a gyönyörű barátnőmmel. Which means like date night with my beautiful girlfriend. And it generates an effect that is good for some sexy time at home. Alright, so how it works, let's see that. So basically there are free services. Let me just turn them off. So free services in the background. First of all, there's a speech to text, which is supported by Google, and it's, I set it to Hungarian. Theoretically, any language.
Inside the browser, so.
Yeah, so any language works that the Google speech to text supports. Then the Hungarian text goes through a translation API of Google. And then the English sentence is sent to OpenAI, which is a public service that is a text-based AI, and it's able to generate an output for your input. And yeah.
Do you have to pay for every request you make?
Yeah, I have to pay for every request, so it's a negative balance for it, but it's very cheap. So every sentence for OpenAI is like 1 or 2 cents. Like sentences like this.
But it's a generic classifier, right?
Yes, it's a generic classifier. So When I said that it generates an effect for you, I lied, because actually I have 9 hard-coded categories, which is sporty, sexy, relaxed, interesting, colorful, annoying. And you know, when I said I don't want to get asleep, it's understood that it should choose the annoying effect. So the OpenAI just categorizes your sentence to one of these categories. My long-term vision, yes.
Date night always means sex for OpenAI?
Not necessarily. So I try different settings. So, you know, it's AI, so you don't really know what happens, but it generally works good. So for example, for spirituality, I tried sentences like, I want to do some yoga. And yesterday, it categorized as spirituality, but today it didn't. So AI works like this undeterministic way.
Yeah. But for example, like you mentioned date night, we actually experimenting with the substance, and basically date night was party.
Yeah, sometimes date night was party as well.
That's
So
why the beautiful girlfriend needed to transform it into
You never know what happens at the end of the date night. So.
yeah, whatever. So my long-term vision with this project, but that really requires a lot of work, so I just chose this very easy use case for OpenAI, is to, theoretically, it's able to generate the whole JSON for me. So this time I had these 9 hard-coded effects preloaded into the project, but in theory I can teach the structure of my JSON descriptor, and it's able to generate any kind of new effects based on a sentence, for example. So that's what I wanted to show you. I spent a lot of time, I feel, so I'm gonna just finish it here.
I guess you will spend insane more time on this project, and I hope you will enjoy all of it. So Johnny will also be around. You can catch him after the third session, I hope, and ask some more questions if you're interested. Thank you for coming, and as a good example, Johnny is not our employee, and by this I would like to highlight that we are welcoming everyone, so if you have an idea you would like to share with this community in the future, please reach out to us. You have a lot of contacts, Facebook, everything, you can write to me, write to any of the organizers. Let us know, we are curious what you come up with, because this is our hobby. And next time we would like to have you here. Thank you.